Welcome to the first of a few Guardium quick technical demonstrations that we're going to be doing. This one's related to Mongodb Atlas monitoring with Guardium version 11.3 using a new function called universal connectors. So what's a universal connector? Well, that's how that works is there's some external data. This can be something like a CloudWatch log or some files. We're going to use FileBeat later on. You'll see what that's about. Syslog, some kind of input mechanism like that goes in through an input plugin. You can code your own if it's exotic, or you can use an existing Logstash input plugin. That gets forwarded to a filter plugin. That's what does some of the work here in translating whatever comes from the input plugin into a format that Guardium can consume. From there, Guardium consumes it and puts it through a policy and stores it into the Guardium internal database, just like any other traffic you would from the STAP. So that's pretty useful. The Guardium policy that you already have defined gets used, and same thing with all the reports. So in this example we're going to show is with Mongodb Atlas. So I didn't want to build my own input plugin, so instead I wrote a little script to offload data from the Mongodb Atlas audit data API. That stores the data in a directory, in a set of files, and then that's consumed by the FileBeat agent, a FileBeat agent. That's a Logstash agent that monitors, sorry, not a Logstash agent, an Elastic agent that monitors the changes to files and any creation of new files, and sends the data to a Logstash server. In this case, Logstash server is on the Guardium collector. There's a Beats input plugin that just comes with Logstash, so we're going to use that. And then we're going to use something IBM provided, which is the MongoDB filter plugin, to get the data into a format that Guardium can understand and put through its policy. So let me show you what that looks like. So first thing is my target. Target is this MongoDB cluster. It's called guard test. So this is the one I want to monitor over here. It has auditing enabled. So on advanced and in database auditing, it's switched to on. Then the filters are wide open, but you can change these so that you can filter some information in MongoDB if you like. But if you filter it, then Guardium's not going to read it. But that is an additional area of filtering. Maybe you only care about, let's say, modifications to data, so that you can, just send those events through the audit mechanism. So that's our target. How do we get the data? Well, we get the data via this API, which is the Mongodb Api Logs entry. And so we're going to get a file called a bunch of GZ files that will allow us to that have the audit data inside it. So Mongo audit log here, MongoDB audit log, and MongoS audit log. And so I built a little script, a shell script, to go and pull these logs. I'll bring that over here. Okay, so this is the script. Goes and gets the data and sort of appends a certain timestamp to the data and all that kind of thing. There's some there. And then downloads the data to a GZ file and then unzips the file. That runs every 5 minutes. The data is generated every 5 minutes. It runs through cron tab. So and that's what the MongoDB API document suggests. So that runs every 5 minutes, and what ends up happening is these GZ files get created, one every 5 minutes, and then they get decompressed into these JSON files. And if we look at what one of the JSON files looks like, you can see these are MongoDB audit records. This is the stuff that we want to import into Guardium. So we're gonna now we got the files. They're on this Linux server. Now we're going to tell there's a FileBeat agent running on here. There's FileBeat, right? We could take a look at the configuration for FileBeat and see, okay, so it's going to a collector 10.10.9.1.1.4 that's going to consume this data as a FileBeat. So here is 10.10.9.1.1.4. Just log in. Here's the universal connector configuration. So I have one here, MongoDB FileBeat. Nice thing about this is this will actually also just work with the default, so you don't have to configure your own. But if you wanted it to listen on a different port, or if you had something else you wanted to do with the incoming stream, that's all configurable in this area. So you provide your input configuration and your filter configuration. If you're familiar with Logstash parameters and the like, that'll probably all make sense to you. The data then gets ingested by Guardium. It goes through the same policy as I mentioned before. It gets stored in the same database. So here's what Mongodb Atlas data looks like inside Guardium. I have some records here that I created earlier from a user called John over here. But I'll show this working just a little bit by maybe running some more commands, and we can see if they show up. So let's go db dot. So I'm connected to the MongoDB cluster here. So guard demo dot insert. We'll just insert, so hello world, simple document like that. db.guard_demo.find. Okay, there's there it is, and then we can go db.guard_demo.drop. So now it's gone. We'll find again. All right. So now, as I said, the data collection process, retrieval from MongoDB takes 5 minutes. The script runs every 5 minutes, and Guardium's got to ingest it. So it should be here soon, but I'm not going to make you wait on the recording. So I'm going to stop here, and then we'll add the rest later. I'll show you the results later. Okay, and here it is. You can see our executions to guard demo over here, which are the new ones. Then if you're curious, here's what it looks like. That's what our full SQL record looks like for MongoDB Atlas record, which are, it's just the raw audit records. This is very similar to regular MongoDB auditing if you do it with an on-prem device and an STAP. Same kind of thing. If you use the exit. All right, so that's how it works for the universal connector, monitoring MongoDB.